Welcome to Review Central Science Proficiency Reviewer Drills, featuring drill questions on molarity. Science proficiency is a typical subtest in many exams, including most scholastic admission and scholarship qualifying tests and some professional licensure and certification exams. If you are eyeing or are set to take any of these tests, then this reviewer is intended for you. There are 13 carefully curated questions featured on this reviewer. Most of the drill questions featured here are designed to hone your skills in solving molarity-related science problems. Some of the questions are modeled on actual questions that appeared on various science proficiency subtests, most notably from college entrance tests in the Philippines such as the UPCAT, DCAT, and USTET. Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Let's begin. Drill question number 1. Which of the following is the correct formula for molarity? A. Molarity is equal to the moles of solute divided by liters of solvent. B. Molarity is equal to the moles of solute divided by kilograms of solvent. C. Molarity is equal to the grams of solute divided by liters of solution. D. Molarity is equal to the moles of solute divided by liters of solution. E. Molarity is equal to the mass of solute divided by liters of solution. The correct answer is D. Molarity is equal to the moles of solute divided by liters of solution. Molarity is a unit of concentration expressed as the number of moles of dissolved solute per liter of solution. For example, a 0.25 moles per liter of NaOH solution contains 0.25 moles of sodium hydroxide in every liter of solution. Chemists use molarity to quantify the concentration of a solution, allowing them to compare concentrations while calculating chemical reactions and working with chemical solutions. A concentration is a term used by chemists to describe the quantity of material dissolved in a given amount of solution. Drill question number 2. The correct formula to find the number of moles of solute is A. Moles of solute equals mass of solute divided by its molar mass. B. Moles of solute equals mass of solute times its molar mass. C. Moles of solute equals molar mass of solute divided by grams of solute. D. Moles of solute equals molar mass of solute times grams of solute. E. Moles of solute equals mass of solute divided by liters of solution. The correct answer is A. Moles of solute equals mass of solute divided by its molar mass. A mole, abbreviated to mol or mole, is a very large number used to measure atoms, electrons, ions or molecules, and is equal to 6.022 times 10 raised to 23. This is known as Avogadro's number or the Avogadro constant. Don't worry, you will hardly need this difficult to memorize number in solving most molarity problems. The number of moles of solute is equal to the mass of solute divided by the molar mass of solute, where mass is measured in grams and molar mass, defined as the mass of 1 mole of a substance in grams, is measured in grams per mole. If you don't know the mass of the solute, weigh it on a scale and record the value. To find the molar mass of the solute, refer to a periodic table. If the solute is a single element, calculate the molar mass of that element. If it consists of more than one element, that is, a compound, calculate the molar mass of the compound. Every element has a different molar mass. For example, 1 mole of sodium has a molar mass of 22.9898 grams per mole. 1 mole of chlorine is 35.4530 grams per mole. If your solute is table salt, an ACl, it is a compound of sodium and chlorine. To find the molar mass of NaCl, you add the mass of each element. Work out 22.9898 plus 35.4530 equals 58.4538. For most molarity problems, it is often enough to use molar masses rounded up 1 to 2 decimal places, or even to the nearest integer. By the way, take note that although the terms molar mass, atomic mass, and atomic weight are distinct from each other and have nuanced characteristics and definitions, they are used interchangeably by many, and are essentially the same number in the periodic table of elements. So don't get confused if you encounter them in some molarity problems, including in the following drill questions. Drill question number 3. How many moles of CO2 does 88 grams of carbon dioxide contain? A. 2. B. 3. C. 3.5. D. 4. E. 5. The correct answer is A. 2 moles. To find the number of moles, divide the mass, in grams, with the molar mass of element or compound. The mass of our solute, CO2, is given as 88 grams. But what is its molar mass? So next step is for us to figure out the molar mass of CO2. Molar mass of CO2 is equal to the atomic mass of carbon, which is 12, plus 2 times the atomic mass of oxygen, which is 16. We should get 44 grams per mole. For our final step, we substitute the given value of CO2, which is 88 grams, and our computed molar mass of CO2, which is 44 grams per mole. We should quickly arrive at 2 moles as our final answer. Drill question number 4. Seawater contains roughly 28.0 grams of NaCl per liter. What is the molarity of sodium chloride in seawater? A. 0.355 m. B. 0.479 m. C. 0.488 m. D. 0.499 m. E. 0.610 m. The correct answer is B. 0.479 m. Recall the 2 formulas we need to compute for the molarity of a solution. Molarity equals moles of solute divided by volume of solution, in liters. And moles of solute equals mass of solute, in grams, divided by the molar mass of solute, in grams per mole. Just like in the previous drill question, the mass of solute is given. It is 28 grams of NaCl. To get the moles of solute, we need to first find the molar mass of sodium chloride. The atomic mass of sodium is 22.989769. We can round it up to 23. The atomic mass of chlorine is 35.453. We can round it off to 35.4. From here we simply compute for the molar mass of sodium chloride and arrive at 58.4. Step 3. With the molar mass of NaCl now known, we can now compute for the moles of solute. We'll get 0.479 moles. And for our final step, it was clearly stated that the 28 grams of NaCl was per liter, so the volume of solute is already given as 1 liter. Therefore, the molarity of sodium chloride in seawater is 0.479 moles divided by 1 liter, which is equivalent to 0.479 m. Drill question number 5. What is the molarity of 5.30 grams of Na2CO3 dissolved in 400.0 milliliters solution? A. 0.125 m. B. 0.115 m. C. 0.105 m. D. 0.250 m. E. 0.225 m. The correct answer is A. 0.125 m. This is very similar to the previous drill question, but instead of sodium chloride, we are being asked to find the molarity of sodium carbonate, Na2CO3. Our first step, as usual, is to recall our 2 formulas, as shown. Step 2, we find the molecular mass of sodium carbonate. For this we need the atomic masses of sodium, carbon, and oxygen. We'll arrive at 106 grams per mole. Step 3, we can now compute for the moles of solute, which is 5.30 grams divided by 106 grams per mole. We'll get 0.05 moles. For our last step, we divide our computed moles of solute of 0.05 moles by the volume of our solution, which is 400 milliliters, or 0.4 liter. We should quickly arrive at 0.125 m as our final and correct answer. Drill question number 6. What is the molarity of 5.00 grams of NaOH in 750.0 milliliters of solution? A. 0.127 m. B. 0.150 m. C. 0.167 m. D. 0.172 m. E. 0.184 m. The correct answer is C, 0.167 m. This is yet another question very similar to the previous drill questions, in which we are asked to find the molarity of a solution, given the mass of solute and the volume of the solution. By now you should already be very familiar with our steps. We now jump straight to step 2 to get the molar mass of our solute, which, this time around, is sodium hydroxide, and AOH. We'll need the atomic masses of sodium, oxygen, and hydrogen, which are 23, 16, and 1 respectively. We should arrive at 40 grams per mole. Step 3, let's compute for the moles of our solute sodium hydroxide, which is 5 grams divided by 40 grams per mole. We should get 0.125 moles. And for our final step, we compute the molarity of our solution. 0.125 moles divided by 0.75 liter. The molarity of our given sodium hydroxide solution is 0.167 m. Drill question number 7. The molarity of 10.00 grams of NaOH in 1,900 milliliters of solution is A. 0.125 m, B. 0.152 m, C. 0.178 m, D. 0.252 m, E. None of these. The correct answer is E. None of these. Just like our just completed drill question, question number 7 also involves sodium hydroxide, NaOH, so we can jump straight to step 3 of our solution. Given the mass of solute as 10 grams, and having computed the molar mass of sodium hydroxide from the previous drill question to be 40 grams per mole, our moles of solute this time around should be 0.25 moles. Computing the molarity of our given solution, we divide 0.25 moles by 1.9 liters, from the given 1,900 milliliters. The resulting answer is 0.132 m. 0.132 m is not in any of our given answer choices, so the correct answer is E, none of these. Drill question number 8. What is the molarity of a solution made by dissolving 20.0 grams of H3PO4 in 50.0 milliliters of solution? A. 1.08 m, B. 2.08 m, C. 3.08 m, D. 4.08 m, E. 5.08 m. The correct answer is D. 4.08 m. For drill question number 8, our given solute is H3PO4, which is phosphoric acid, a colorless, odorless phosphorus-containing solid, an inorganic compound. It is commonly encountered as an aqueous solution, which is a colorless, odorless, and non-volatile syrupy liquid. Except for the different solute, this question is essentially the same as the previous ones in this drill so far. The mass of solute and the volume of solution are both given. Let's proceed to find the molar mass of H3PO4. We multiply the atomic mass of hydrogen, which is 1, by 3, add the atomic mass of phosphorus, which is 31, and add the atomic mass of oxygen, which is 16, after multiplying it by 4. We should get a molar mass of 98 grams per mole. Proceeding to step 3, we now compute for the moles of solute, which is 20 grams divided by the 98 grams per mole that we just derived above. This should result to 0.204 moles. And for our final step, molarity of solution equals 0.204 moles divided by 0.05 liters, from 50 milliliter of solution. The correct answer is 4.08 m. Drill question number 9. 0.450 mole of NaCl are dissolved in water, resulting to a 95.0 milliliter solution. Calculate the molarity of the sodium chloride solution. A. 4.5 m, B. 4.7 m, C. 4.8 m, D. 4.9 m, E. 5.0 m. The correct answer is B. 4.7 m. For drill question number 9, the moles of solute is already given as 0.450 moles. Therefore, we can altogether skip the steps to compute for the molar mass of sodium chloride and the moles of solute. We go straight to computing the molarity of the solution. Molarity equals moles of solute, which is given as 0.45 moles, divided by the volume of the solution, which is given as 95 milliliter, or 0.95 liter. The answer is 4.7 m. Drill question number 10. 15 grams of NaCl occupy a volume of 75 milliliters. What is the molarity of the solution? A. 3.4 m. B. 3.6 m. C. 3.8 m. D. 4.0 m. E. 4.2 m. The correct answer is A. 3.4 m. From drill question number 4, we've already computed for the molar mass of sodium chloride to be 58.4 grams per mole. With a mass of solute given as 15 grams, the moles of solute should be 0.26 moles. Therefore, the molarity of the solution should be 0.26 moles divided by 0.075 liters, or 3.4 m. Drill question number 11. 45.0 grams of CaNO32 was used to create a 1.3 m solution. What is the volume of the solution? A. 110 milliliters. B. 115 milliliters. C. 190 milliliters. D. 210 milliliters. E. 250 milliliters. The correct answer is D. 210 milliliters. For drill question number 11, our solute is CaNO32 or calcium nitrate, an inorganic compound. Another name for calcium nitrate is norgesalpeter. It was synthesized by the Birkeland A process at Notodden, Norway in 1905. It is a nitrate salt of calcium which contains calcium and nitrogen and oxygen. The molar mass of calcium nitrate is the sum of the atomic mass of calcium, which is 40, plus 2 times the atomic mass of nitrogen, which is 14, plus 6 times the atomic mass of oxygen, which is 16. We should arrive at 164 grams per mole. Hence, the moles of our calcium nitrate solute should be 45 grams divided by 164 grams per mole, or 0.27 moles. For this drill question, we are already given the molarity to be 1.3 m. What we are asked to find is the volume of the solution. From our molarity formula, molarity equals moles of solute divided by volume of solution. We simply transpose volume of solution and compute it as mass of solute divided by the molarity of the solution. Therefore, the volume of our calcium nitrate solution is 0.211 liter, or 211 milliliters. From the answer choices, the closest answer is 210 milliliters. The 1 milliliter difference can be attributed to rounding of some decimal numbers somewhere along the steps. Drill question number 12. What is the molarity of sodium chloride in river water? A. 0.288 m. B. 0.455 m. C. 0.488 m. D. 0.510 m. E. None of these. The correct answer is E. None of these. In drill question number 4, we were asked to find the molarity of sodium chloride in a liter of salt water. This time around, we are asked to find the molarity of sodium chloride in river water. So how do we proceed to answer this molarity question? Well, first of all, river water is considered fresh water and, unless stated otherwise, fresh water does not contain sodium chloride or salt. A certain type of river water, that is brackish water usually found in river deltas and lagoons, do contain some salt. But then again, unless explicitly stated, we'll have to assume that our river water in the question is purely fresh water. Hence, the mass of sodium chloride in our solution is 0 and, it follows, that moles of solute is also 0. Therefore, we cannot compute for the molarity of sodium chloride in a freshwater solution because there is no sodium chloride in it. Drill question number 13. How many moles of CaNO32 are there in 75 milliliters of 0.25 m solution? A. 0.0188 moles. B. 0.0194 moles. C. 0.0200 moles. D. 0.0321 moles. E. 0.0440 moles. The correct answer is A. 0.0188 moles. For our last drill question on molarity, we are again given a solution containing calcium nitrate, just like in drill question number 11. But here we are already given the molarity of the solution to be 0.25 m, and its volume is 0.075 liter. What we need to find is the moles of our calcium nitrate solution. From our molarity formula, we can compute for moles of solute given the molarity and volume of the solution as moles of solute equals molarity times volume. We should arrive at 0.0188 moles as our answer. To wrap up our science proficiency drill on molarity, let's summarize the concepts and formulas we have used to answer the preceding chemistry problems. For molarity problems, you will probably need to remember only two formulas. Memorize these as much as possible. The first one is the formula to find the moles of solute. Oftentimes the mass of solute, in grams, is given. This is not yet your moles of solute. To find moles of solute, you will need to divide the mass of solute with the molar mass of solute. And to get the molar mass of your solute, you need to know its chemical composition and the corresponding atomic mass of each element involved. This is usually the most difficult and challenging part of solving molarity problems, because oftentimes test makers assume, or expect, that you know. First, the chemical composition of certain common compounds such as sodium chloride, methane, calcium nitrate, sodium hydroxide, ammonia, etc. And second, the molecular mass of the elements involved in these common compounds. At the very least, you should know the molecular masses of hydrogen, oxygen, nitrogen, sodium chloride, potassium, phosphorus, and a few other elements, if you hope to be able to solve molarity problems. The second formula that you should remember is, of course, the formula to find the molarity of a solution. Molarity is equal to moles of solute, which you probably obtained by using your first formula above, divided by liters of solution. In most cases, this is simply and plainly given. However, some test makers may throw in a little complication to confuse us. One usual trick they use is to separate the volumes of solute and solvent used in the solution, in which case you simply add these to get the volume of the solution. Another trick they use is to give the volume of solution in units other than liters. Just remember that volume of solution needs to be always expressed in liters, so if some other unit is given, such as milliliter or maybe even ounces, then you need to do the appropriate unit conversion first before proceeding with your molarity computation. If you wish to learn more about molarity of solutions, you may check out some links that we have included in the description below. You have just watched Review Central Science Proficiency Reviewer Drills, featuring drill questions on molarity. The drill questions we featured in this particular episode have been carefully curated to present to you as many of the typical molarity-related questions that appear on science exams. If you wish to watch more Science Proficiency Reviewer Drills, check out our Science Proficiency Reviewer Drills playlist. Check out also our other reviewer drill playlists for other topics. If you haven't done so yet, please don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful and feel free to share to anyone who may also benefit from it. We wish you all the best on your forthcoming exam.